All right, the 6.3 homework assignment. At first glance, it appears to be a longer homework assignment, but what I think you'll see is a lot of these problems go really quick. The first three, for example, are just asking you about the restrictions that we put on the domains of sine, cosine, and tangent in order to define arcsine, arccosine, and arctangent. So all you gotta do is write the correct interval for arcsine, the correct interval for arccosine, and the correct interval for arctangent in these three different spots. And then you're done with the first three problems. Be a little bit careful with your open and closed parentheses and make sure you're writing these in interval notation, and you should be good to go. Questions 4, 5, and 6 get you practice with arcsine, arccosine, and arctangent. Note the obnoxious way that they write these. This should say arcsine of 0 and arcsine of negative root 2 over 2. But it doesn't. What are you going to do? What you're supposed to do is find an angle. They even give you the bounds in which the angle must lie, so I guess they're kind of telling you the answer to question 1 here. But fine, whatever. Answer these three questions, make sure your angle is in radians, and you are good to go. Then you do it again for question 5, except instead of the questions being about arcsine, they're about arccosine. So there's a different interval in which your answers must lie. Hopefully you can figure these values off your unit circle and move on to question 6. Same thing, except now we're talking about arctangent. A little bit more challenging because most students don't have the tangent values memorized as well. But if you remember, there's not that many values that come out of the tangent function on your unit circle. Maybe you can kind of match these up with the appropriate angles and be 6 problems deep into the homework already. Then we get to the section where we start doing function composition. Note that for questions 7 and 8, the function on the inside is the trig function and the inverse trig function is on the outside. So these two should match up with the second of the 3 videos that I made from this section. Nothing too tricky going on in either one. And then the remainder of the assignment until you get to the extra credit question has inverse trig functions nested inside trig functions. So unlike this one where arcsine is on the outside, in this one arccosine is on the inside. Because these are values off your unit circle, you can do them in either of the 2 methods that I depicted in the 3rd video. But I think the triangle method will make your life easier. And eventually, as you start going through these problems, you'll find some that you have to use the triangle method on. I think question 12 is the first one where you have to use the triangle method because 5/13 and 12/13 are not x and y coordinates of angles that you have memorized on your unit circle. 13 is more of the same, and then you get to 14 and 15, and it looks different because you got letters floating around, but I did an example where you have letters floating around, and hopefully it won't mess anything up for you. My little hint is think about this as m over 1, and this is x over 1. And I don't know for sure, but just in case this thing is case sensitive, since this is a capital M, use capital M's in your answer. Similarly, down here, use a lowercase x. The last one on the homework, so as always, it's extra credit, and in this case, it certainly should be extra credit because I have not shown you how to do this at all. I haven't done examples similar to this. Nowhere in this section did we do anything like this. However, I think you can figure it out. What they're asking you for is for the inverse function of this function. If you think all the way back to the first thing we learned in this class, you might remember that finding the inverse function for a function is a 4-step process. That's the one where change f of x into y, switch your x's and your y's, solve for y, change that y into f inverse of x. Oh, okay, so why is this in this section? Well, because in that 3rd step where you're solving for y, you'll have to get this variable, which will be a y at that point, all by itself. You'll have to get rid of this sign. But I think what you'll see is if you can isolate sine of y, you can then use the arcsine function to get this variable all by itself. And once this variable is all by itself, you will have solved for the inverse function. You can put it in this box. If that makes sense to you, if you can do all that, that's fantastic. But if not, don't worry about it too much. This is one of those extra credit questions that is beyond anything you need to be able to do for our class.